Today on the Perception and Action podcast, how do we conceptualize transfer of training from an ecological point of view? What elements must be present in practice for it to result in an improvement in competition? So it's time for a call to action. Hi, this is Rob Gray from Arizona State University. I've been on a now over 25-year journey as a researcher, professor, and high-performance consultant to understand how we acquire and adapt our perceptual motor skills. Welcome to the Perception and Action podcast, where I discuss how psychological research can be applied to improving performance, accelerating skill acquisition, and designing technologies. Now on to the show. Hi everyone, this is Rob Gray from ASU and the Perception and Action podcast. What I want to talk about today is the issue of transfer of training. How do we know what we're doing in practice is going to actually make us better in competition? A question that people have been interested in for a long, long time. What I want to focus on in this presentation is how we approach that question from an ecological approach. And of course, what we're talking about is the main theoretical construct that goes under this is the representative learning design. So this is the part of the presentation I gave at the Baseball Skill Acquisition Summit. So I'm going to cover what is transfer of training, theories of transfer, the concept of specificity of practice, then turn to the ecological approach to this with looking at representative learning design, and then talk about the issue of negative transfer of training, the idea that what we do in practice actually might make us worse in competition, how we address that, and then talk about training action capacity versus skill. So what is transfer, right? So transfer, what we're talking about is the gain or loss in ability to perform one task, a criterion task, as a result of practicing some other task, turn the transfer task. So in sports, the main criterion task we're talking about is the game or the competition. The transfer task is whatever we're doing in practice. So in baseball, the transfer task might be hitting off a machine in a batting cage. Criterion task might be hitting off a pitcher in a game. Okay, so there's many dimensions to practice. I mentioned practice transfer can be positive or negative. Practice can make you better or worse. It can be weak or strong. There's also this dimension of distance. So you can have near transfer. Near transfer occurs when the criterion task is very similar to the transfer task, right? So if I trained you in a batting cage on hitting off a machine, then I tested your ability to hit off a machine on the field, say, that's very near transfer. There's not much difference between what you practice and what you're competing against, right? So versus far transfer, if I went from a machine in a batting cage to a game against a pitcher, those are very dissimilar, very far apart. That's the jump we want to make. And really that's what we're aiming for in all practices, far transfer to the game. Right? And that should be the gold standard, I think, for evaluating practices. Why is this important, right? Well, when we start talking about sports technologies, when you look at the evidence for a lot of them, Dynavision, NeuroTracker, so on and so forth, most of the evidence that people give you to support buying their device or whatever it is near transfer. What they basically show is practicing on their device makes you better at their device. Right? They have certain metrics like S2 cognition, that this device where it gives you all these decision-making and reaction measures. The main thing that they demonstrate is you get better at the actual thing itself, right? That's near transfer. And I always say we need to beware of that, right? Because you get near transfer for everything. Everything we practice, we get better at that thing, right? If I play Candy Crush on my phone, I get better at Candy Crush. Does that make me better at anything in the real world? No, right? And as evidence for that, you can go back and listen to some of the episodes. For example, I talk about Lumosity. There was another company called Ultimize. Both of those companies were fined by the FTC because they made false claims about far transfer. They made claims that using their app on your phone would affect something in the real world. That's far transfer, like your ability to find your car in a parking lot or your ability to, play sports. From my take of the field, there's no evidence to support those claims. And obviously the FTC agreed. That's why they got fined. Right. So just a warning there. So what are theories? What do people think about how you produce transfer? So how you get what you do in your practice to improve you in the game. So positive transfer. The first real theory of this is called the common elements theory, proposed by Thorndike. And it captures a basic theme you'll see throughout the theories. The idea that there's got to be a lot of similarity between what your practice environment's like and what your competition environment like. Thorndike was very, very hardcore about this. His theory motivated, for example, the design of the Link flight simulator in the 1930s, where the flight simulator actually had wings and a tail on it, right? So, modern flight simulators are a computer screen, but you don't have the mechanics of a plane that put it in the air. We don't think those are necessary. Another example of this from an information processing view is the instance theory of Lanegan, the idea that skill involves matching a current event to some template you have in memory for a similar event, right? And a very common view people have in team sports now. I recognize that's the defense, that's the play. I know how to respond. Lanegan proposed that the similarity between the number of things that share in common between the event you experience in practice and the competition events will get better transfer. And then you have the really good work by a person named Luc Prateau on specificity of practice. This was mostly focused on the information you're using, particularly from different senses. He did some really interesting experiments where he had people do a reaching task. So they had to reach and pick up something on a desk, say. And he trained people in the complete darkness, so they couldn't see where their hand was going. All they could see was the target. So they didn't get any online feedback of where their hand was, and which is harder, right? It's a harder condition. But what he found was when you trained in the darkness and transferred people into a condition in light where they can see their hand, it actually got worse, right? He argued that we learn to use information in a certain way in practice, and that when we change that, even for the better, it can hurt our performance. So those are some of the theories. So from these, you can see the general idea, and I'm going to come back to this in a second. This general idea that there's got to be some similarity between what we're practicing and what we're going to compete in, right? This idea of specificity is starting to come out. And this is really, here's a quote from Smith and Lee's Motor Control and Learning textbook. The general hypothesis that we should attempt to match those conditions in acquisition practice with those expected in the criterion test performance is an old one based on common sense. It has been called the specificity of learning process hypothesis and motor behavior, right? And it stems from some very old work. This idea of specificity, things have to be similar, right? And this raises, I always laugh because this raises an inconvenient truth, right? This truth, we want to deny this. For some reason, we try to deny this all the time by making technologies on our computer. The idea that it is basically true, right? You can't get good at a thing without practicing that thing, right? You can't get good at playing tennis without playing tennis, right? Not only is that common sense, it's true. You'll only get transfer from very similar things, right? So we can deny this all we want, but it's true, right? You have to practice the thing. But what this has led to is kind of this general view of what specificity means, right? So this kind of overall view that we need to have things in practice. There's kind of everything in practice should be like the game, right? Or as many things as possible, as close to game-like as possible is kind of what I think the specificity idea is kind of turned into now. For me, I don't find this very useful, right? The idea of specificity of practice. It really doesn't give you much guidance about what exactly needs to be the same. Everything, right? And can we not practice baseball unless we have fans there, right? Can we not practice baseball unless we have a scoreboard, unless we have green grass, right? Does that mean we can only get better at a thing if we just play the game? That's something I've kind of argued against in previous episode. I don't think the game is a good teacher, the best teacher for skill. And also, if that was true, then we couldn't implement in practice some of the things that we know are beneficial from a lot of other older research, for example, from some of the Russian work. For example, overload and underload of implements, right? Throwing a weighted ball and an underweighted ball has benefits. We can't do that if we strict specificity, because throwing a 7-ounce ball is not specific. Right? You're never going to do that in competition. We can't really exaggerate or amplify information and affordances, for example, in small-sided games. A small-sided game is not specific. It's not like competition at all, right? But we know it has benefits in terms of the information. And we can't create an environment where you're going to get a lot more reps, touches, whatever. For example, in a small-sided game, because that's not game-like, right? So those are some of the limitations I see with the general idea of specificity. So I think a much more valuable approach, a much more useful approach, is how we look at it from ecological view, which is the concept of representative learning design, right? And to understand this, we need to take a step back and understand what we think is acquired when you learn a skill in the ecological approach, right? Learning in is all about establishing a functional relationship between information you pick up in environment and your movement affordances, right? And because the constraints are always changing in the competitive environment, you're playing against different opponents, different situations, you're getting tired, all these things are happening. We constantly have to change this relationship, right? If we're going to be successful. In order to repeat successful outcomes, we can't repeat the same movement solution. Repetition without repetition, right? So being skillful, and I love this from, this quote, being skillful is not a process of repeating a solution, it's repeating the process of finding a solution. So movement, success in sport is a problem-solving activity where we constantly we're not just pulling out the same movement pattern over and over. We're constantly finding a relationship between information and movement that will work given a set of constraints, right? So that's the key idea of how we think we learn, right? And, this happens in three ways. These changes, they're covered in the theory of direct learning. We're going to change the information we use, which is called the education of attention. We're going to change what aspect of movement we control, which is called education of intention. And we're going to train the relationship between the two of them, which is calibration. Right? So those are the three things that we think we have to change about this relationship. And how we become a good problem solver is by being able to do these to satisfy the current constraints. Okay. And so this is the fundamental idea, right? The fundamental difference between traditional coaching and the ecological approach. We're not trying to teach you the solution or build knowledge or motor program or motor memory or whatever you want to call it for one movement pattern that you're going to use in the game, right? We're going to try to improve your ability to find a solution, right? So this brings up the fundamental, I'll go over this a little more. It brings up the fundamental idea of the soft assembly, right? So to be skillful in the ecological approach, we need to form a temporary organization of the degrees of freedom in our body that will get the job done given this set of constraints. It's soft because it's going to fall apart once that these constraints disappear. We're going to do a new assembly. We're continually making new ones. Okay. So that versus a hard assembly where it's always the same in across situations, right? So in terms of transfer, this raises the idea that any movement problem faced in practice that has the same basic structure, I'm going to talk about what that means, the criteria for that in a second, as the one in facing competition will transfer to competition, even if it's a problem that you never face in competition, right? Because the act of having to solve the problem is useful, right? It makes you better able to solve problems in competition, which you have movement problems. That's the fundamental idea. So a key point here, the movement problems we create in practice do not need to be ones that we face in competition. That's why we can throw a 7-ounce weighted ball in practice, something we will never, ever, ever be asked to do in baseball. And it's valuable because finding a way to control the flight of that ball by adjusting your movement using the information you get from feeling the ball is useful. It makes you a better movement problem solver. It's teaching you how to be a movement problem solver. So the process of adapting the problem in and of itself is going to improve skill. We're not trying to get you a set of solutions to particular problems you face in a game. In my first book, I called this the difference between adjustability and adaptability, right? Adjustability is where you start with a particular movement solution, a golf swing, a baseball swing, that you learn, drill, repetition. You learned it under the same, how do I hit a fastball? Let's hit 100 fastballs. I get the motor program for that, or hit a golf off a flat ground. I get the motor program for that. Then what I'm going to do is adjust that motor program, reparameterize it based on situations I might face in the game, right? So, I might, we might face in the game. So we might have to learn. So once we get the basic program, we have to learn how to downhill lie, uphill lie, outside pitch, right? So what we're focusing on, we do want to be able to vary our movement program, but we want to do it in a very just specific way to specific things we're going to face in the game. That's what I mean by adjustability. Adaptability, right, is learning to make these soft assemblies, learning to find a solution to movement problems that some of them that you will never ever face, right? Using a weighted ball or weighted bat, those, we're giving you new movement problem that we know you're never going to face in the game. You're never going to swing with a long bat in the game, but you solving that movement problem is going to improve your movement solving abilities, make you more adaptable. That's what we're going for. Okay. So representative design. Okay. So representative design, the analogy I like to use, right, is taking a slice out of the game. Okay. So we're going to, just like when we go to get a piece of cake, we're going to take a slice out of the game, right? We're going to, we're going to focus on one thing, bat speed. We're going to focus on one thing, control, pitch velocity, so we're going to focus. We're not going to do everything all at once, right? We're going to restrict practice in some way. But I don't know about you. When I go to get a slice of cake, right? When I take a slice of cake, I want all the parts of the cake when I take a slice, right? I want some icing. I want some cake. I want some of the stuff in the middle, whatever's in the middle, raspberry filling or whatever it is. I want all those things, right? That's what we're going for in representative design, letting the slice represent the whole, right? Because it has all the key elements. Traditional practice is just scraping the icing off the top, right? Hitting off a tee is scraping the icing off the top. You're practicing one part of it while you lost a whole bunch of the parts, right? So nobody wants to do that. Nobody goes up to a cake and just wants the icing, right? Okay. So that's the basic idea we're going to. There's certain key elements that we need to be present, right? Parts of the cake in order for it to as long as those are there, then it's going to transfer. Okay. So what needs to be the same? What are the parts of the cake, right? There's 4 things. Okay. First is the information, right? We need movement to be coordinated on using similar information to what we're going to face in competition, right? Practice, or another say is our practice is going to sample from the information available variables from performance context, right? When I hit a ball off a tee, right, the information I'm using is a static ball. I can judge its height above the ground. That's how I coordinate my swing. That's completely different than hitting a moving ball thrown by a pitcher, right? Where I have to get information about time and direction, right? So that's not good representative sampling. Action fidelity. What we mean by that is the movement has to have similar dynamics. The task dynamics has to involve similar coordination, right? Is it a rotational movement? Is it a linear movement? How is the whole body involved or just the upper body, right? So action fidelity is the second. So we need representative of information, representative of movement, okay? The other this third one, right, is representativeness of affordance landscape, right? So in our practice, we want require the person to make decisions, pick up affordances, plural, based on the unfolding information from the environment. That is so critical. That's one of the most important ones, right? And the last one, which we sometimes skip over, we want the emotional environment, particularly the pressure, to be similar to what they face in the competition, right? So those are the 4 things: information, movement, affordances or decisions, and emotional context, right? So let's look at these in more detail. So look at these. I want to look at the typical way we do fielding practice in baseball, okay? So if you've never seen this, go watch before the game starts. You can see while they're doing batting practice, you'll typically see. So you'll have a coach do a traditional fungo. So what the coaches does is they throw the ball to themselves. They'll hit it at the field. They'll hit it to the fielder. And I've seen some of our coaches on the Red Sox are unbelievably good at this, right? They can put spin on the ball of any type. They can hit any location, right? And then they hit it to the fielder. The fielder knows that the ball, they usually say, okay, now it's time to warm up the third baseman. The ball's coming to you. They know it's coming to them. They know they have to throw to first base after they field it, right? So everything's highly predictable. But the problem, if we look at this in terms of information, the reason I don't like this and we don't like this, I'd much rather do what are called front toss fungos, where someone's throwing the ball to the coach and they hit it, right? The information here that the fielder is going to use to come into the ready position to field it is the ball dropping down from up above, which is completely different than the ball approaching the plate, like in the game. So traditional fungos do not represent information well for fielding, right? So that's why, we, in Randy's and I book, we talk about encourage front toss fungos, right? Action fidelities, like a lot of fielding practice you'll watch, people don't do any throws, or they'll do a fake throw, right? This is important because, one of the things we see when we look at kind of biomechanical studies of what happens when you make people catch a ball versus when they have to catch and throw it, what you see is completely different biomechanical patterns when you have to catch and throw than when you're just catching. This is a great example of something called a nested affordance, right? So you have to do two things. You have to catch the ball and throw the ball. What you see is people start nesting one in the other. They actually start the process of throwing before they finish the process of catching, right? So that's really important. So it doesn't mean we always have to have throws, but we need it a lot of times, right? Because, we want this action fidelity, the movement, how it's the mechanics of it, what we have to do, the affordances have to be similar, okay? So that can be a problem, okay? Traditional fielding practice, as a hint, completely lacking decisions, right? Almost always in fielding practice, I know the ball's coming. Okay, now the ball's going at the second baseman. They know they're the only one going to field it. When the shortstop's fielding the ball, they know the third baseman's not going to cut him off and get the ball. They know what base they have to throw to. It's very, very predictable. There's no decision, right? Information about affordances, right? So it's very lacking. It's very lacking in that aspect of representative design. And then lastly, emotion pressure. Most fielding practice happens with no base runner, right? So there's no time constraints, both short and long, right? So in baseball, you want the fielder to throw based on the base runner, right? You don't want to hurry it when you don't have a fast base runner, and you don't want to go too slow when you do have one, right? So you need to kind of have these time constraints available in practice, right, to get used to them, right? So when you break down the traditional way we practice fielding, it's terrible in terms of representative design, okay? Why does this matter? If you look at when we make errors in games, when do errors occur in baseball? They're 60% more likely to occur when the runner's on base. Why? Because there's a decision component there, right? When a ball is hit out and there's runners on base, it's not automatic what base you're going to. It's not predictable, right? Having to pick up the information and make that decision of what bag I'm going to makes the play harder, right? Similar, there's less likely to make error in baseball in every count when there's two outs. Why? Two outs takes out the possibility of a double play, right? So that's one affordance that's gone. It makes the play easier. You don't make errors, right? So this is to say, fielding is a lot more than the biomechanics of catching and throwing, right? Having these decisions in your head as available, picking up these affordances makes it more challenging, right? So let's go into each of these pieces of representative design, talk a little bit more. So we're talking about information. What do we want in the information, right? We want it to be dynamic, right? In most sports situations you face, the information is changing continuously, right? So the speed, like when gaps are opening and closing, the ball is getting closer to me as I go. So affordances are appearing and disappearing, right? So at one moment, like in my fielding example, At one point, when I field the ball, I have a chance to get turned a double play. A fraction of a second later, that's gone, right? Because I waited too long, right? So I need to have information and practice carry this quality for this dynamic information. We want similar sensory modalities. That's just, we want, if the information is primary visual or primary proprioceptive, we want the both. We want to have variability, right? Similar in type and degree of variability, like, in baseball. So baseball, practicing hitting fastballs, you're incredibly good, right? But, and the other, I was just doing some work with basketball. And when you watch basketball practice with NBA players, in normal basketball practice where they're doing a 3-point shot from like a set spot, they hit 70 to 80% of their shots, right? They're incredibly good at it, right? Because they know where they're shooting from. If they, they're doing so, we need to have similar variability in pitch type, pitch direction that we have in the game. That doesn't mean we can scale that down to make the appropriate level of challenge, right? So we don't have to, in batting practice, for example, we don't have to simulate a pitcher that can throw one pitch 60 and one pitch 90 on the outside. We don't have to simulate, Jacob deGrom or somebody, right? That's incredible level of variability. We can scale it back for to make it important, to make it the right level of challenge, right level of success rate. And then specifying, right? The information we present in practice has to be specific to some relevant object or event. What I mean by, right, it's telling us what it affords, what the event is, right? And I'll go into that in a little more in a second, right? So here's an example. One of the things I like to use, these are Drivelines command balls, right? So these are baseballs. So regulation baseball is 5 ounces, right? What you have is balls that are slightly heavier or slightly smaller and slightly bigger diameter, right? So they're wide, they're big. It's absolutely true that you'll never have to throw a 4-ounce or a 6-ounce baseball, right? They don't suddenly get lighter or heavier. You'll never have to form a ball that's 5% bigger diameter. That's not going to happen, right? But if you look at these balls, they meet the criteria for the information. The information, when you pick it up and wield it about, right, you're picking up dynamic haptic information, dynamic touch, Gibson's idea. And the information you get from that ball is specifying, right? That information. So when I pick up a 4-ounce ball and move it around, it's going to cause deformation in my tendons and muscles. And that's going to be unique to a 4-ounce ball of this particular size. And I can use that to perceive the perception, the affordances for throwing. I can use it to adjust my information and movement control relationship so that I can get that ball in the strike zone. And doing that is going to make me solver, even though the problem I'm solving is something I'll never do in the game, right? So I think that's really, really valuable. So we're learning to command these requires recalibration of our control law, right? This is an example. We're taking advantage of overload and underload principle, a principle that's been around forever and shown to be highly effective, right? So I call this is a representative task to me. It has the information available. Obviously, the action fidelity is very high. You're doing the same thing. You're throwing the ball just like you normally would a regular baseball. Okay. Okay. So that's kind of the information. So this brings up a point that I wanted to talk about: negative transfer of training, right? So if I teach a pitcher to throw just their movement, they're throwing their delivery, so they get a 4-ounce ball to go into the middle of the strike zone, or I get a batter to adjust their timing of their swing, so they get to a bat that's 20% heavier than the regulation bat in the strike zone at the right time. Won't that mess them up, right? Won't that mean that, when they go back to a regular bat or a regular ball, they're going to miss, right? I think this concept is way overblown, right? We're not going to expect this because, again, we're not trying to program you to throw a 4-ounce ball. We're teaching you to adjust your control law and softly assemble it so you can achieve that in practice, right? You can still unassemble it and throw a 5-ounce one, right? So we're not creating hardwired motor programs for a particular ball or bat. that's when you get negative transfer. That's not what we're aiming for, right? But there are things we can do to reduce this. Focus on the switching, right? So the switching between them is as valuable as doing 100 reps with the light bulb, right? Having this switch between light and heavy, light and heavy, light and heavy is really valuable. That's really what you want. And I kind of like to use this rule. Whenever I use a weird piece of equipment or constraint, I always like to go back to the actual thing. So let them use their game back at the end of doing heavy and lighted, right? Because we want them to put that new movement pattern into their game conditions, right? So I don't worry about negative transfer training at all from doing these things. I don't think you should either. Action fidelity. So action fidelity, again, the movement degree to which action in practice is similar in terms of the degrees of freedom involved, the forces, the time constraints to what's in competition. Here's kind of like when you're doing a picture recognition app, that's really low action fidelity. I'm hitting off a tee, hitting front toss, soft toss, machine, pitcher, right? So we can kind of have a scale of action fidelity. But we need to have it somewhat similar to get any transfer, right? We need to have similar movement patterns. Here the main difference is obviously information, right? So that's important. So that's what needs to be similar between information and movement. Decisions. What do we need? We need decisions to be emergent. What I mean by that is they're based on the information you're picking up from the unfolding event. Which base should I throw the ball to? That is not, you don't know before the play starts, right? You know based on where the ball's hit at you, where your position is, where the runner is, where the runners are, right? So it emerges from the situation. It's key that practice has that element too. It needs to be embodied, right? You need to be able to learn to make this decision based on your capabilities, right? If I run around and catch that ball and if I run around a tennis shot and play it on my forehand, will I have enough time to get to the ball as versus doing the backhand, right? So I'm doing that based on my own abilities. I have to learn to calibrate my own action capabilities to these decisions. The decisions I can't emphasize this enough. They need to be unpredictable, right? You don't know beforehand. You can't know beforehand exactly what's going to happen and what you need to do. That completely changes things and makes practice not nearly as effective. That doesn't mean that, again, we can simplify if we want to. So a lot of these things, how do we make it easier for the person? You can reduce the number of possible decisions, right? So you can take it from a large number to make it only 3 possibilities. There's a lot of great work people are doing, work in martial arts now, Brazilian jiu-jitsu and stuff. So what you do is you have them fight an opponent where the opponent can only defend in certain ways, right? So it's unpredictable, but you reduce the number of options to make the task simpler. So that's really important. Here's an example of the power of unpredictability. This was a volleyball study. I did a full episode on this one. I really like what they did in this. They're teaching people to hit around blockers, okay, a volleyball attack. They use traditional practice where the person knew exactly where the ball blockers were going to be on every trial. Very predictive, not representative. And they compared it to a constraint set approach where there was 3 possibilities, right? So there's not a huge number. There's not every possibility there, but it's unpredictable. You don't know where the block is coming from or where it's going to be. And what they found is significantly better performance in the end after training when you add this unpredictability, even with a very small number of decisions. So that's really, really critical in terms of the decisions, okay? What about representative emotion and pressure? What do we need? One, we want consequences, right? We want consequences when you don't succeed, right? That's really, really important. Not all the time, but it's really valuable because we know that, for example, choking under pressure occurs when people start turning their attention inwards, right? So there's a big consequence if I fail. If I miss this putt, I'm losing this tournament. We start thinking, what happens if I fail? I better make sure I keep my feet together, keep my head down, right? You start thinking internally, thinking on mechanics, which is deadly for performance, right? So we want to get you used to handling that feeling, right? So having consequences in practice, Consequences do not have to be the same as in the game. That's one of the so there's no way we can create the consequence of you're going to win $10,000 if you make this putt, or you're going to win the World Series if you get a hit. Right? We can, but they don't really seem to have to be the same. There's a lot of research showing this. One of my favorite ones I like to use is making people make a speech in front of their teammates. People hate that. Right? I just want to get it in their head. What happens if I don't succeed here? Similar time pressure. Competition. This is something I've really tried to emphasize. These guys love to compete, right? Just throw a $20 Chipotle gift card out there, right? Just get them something competing, right? That is really, really valuable for getting the motion and pressure similar to competition, okay? So why do we want to do this, right? So we've been emphasizing transfer. Obviously, there's several other things. Better decision-making. There's a bunch of research I've talked about before. It seems to prevent injuries because you're getting more variability in how you execute the movement to perform the same goal. Degeneracy. We get less wear and tear on the athlete. Let me show you some evidence for that. So here's a study that I talked about, a soccer study I talked about in a separate episode. This study looked at teaching people the fundamentals using different approaches. So these were youth players. What they did is train in different groups. A group that did very block practice where they had to dribble around cones and practice a certain way, traditional practice versus constraints-led group, which was small-sided games. They changed the constraints like playing over the ball, having a certain amount of passes, they had all these things. And what they looked at, what they did is basic drill. They used basic tests of skill, very traditional ones. How fast can you dribble around the course of cones? How fast can you perform a passing test where you have to pass to certain spots, right? Very, very traditional. And what they found is for both of them, you get about the same improvements. So it's not the case that you need to isolate and practice, right? That was the main message. But this is an interesting analysis. I got this idea from Derek Penchuk. If you look at the return of investments, so when you do traditional practice where you're going around cones and you isolate and decompose things, right? You're getting more reps, right? So in their study, you did 77 passes in that condition, and you improved by they're on average 1.99 seconds. So if you calculate that out, the rate of return on investment of practice is 0.003 seconds. Okay. Now, if you look at the group that did small-sided games and they followed the ecological approach and representative design, they obviously, when you play a small-sided game, you're going to get much low opportunity. You're going to get less touches. This is reality, right? You're going to get less balls. In baseball, if we hit the balls between the fielders and let the third baseman cut off the shortstop's going to get less reps. That's just the way it is, right? In their case, they only made 354 passes. But they had, a 2.18 improvement, so around the same, not different. But that's a return on investment of practice of 0.006 seconds per pass, right? So that's double, right? So this is a point. When you use one representative practice rep is worth at least two non-representative ones. So what we can do is over the course of a season, if we focus on the quality of practice, we can get less wear and tear on an athlete. That's really a big selling point for me. Highly representative practice is at least twice as valuable as ones with low representatives. So 20 ground balls that are hit right at you where you know it's coming, you're wasting the person's arm, right? You can get the same gains if you did 10 ones that are where they have to make a decision. They don't know what's going to happen, okay? So you get the same gains through making less actual throws, right? So that's a really important point. Okay, so that's the basic idea of representative design. Now I want to turn to, this is something related to what I talked about last year, but I just wanted to go about this. So, but Rob, if we're focusing on transfer training, how in the world will we get transfer training from moving an aqua ball around for hitting, right? The information is not there. You don't have to time the movement of the aqua ball to an oncoming ball. The action fidelity is not there. We're not swinging a bat. We're moving a water ball. There's no decisions. You don't have to decide whether or not to swing. And there's no pressure or time constraints. Why would we want to do this? Why would we expect to get transfer from that, right? When you're meeting none of the criteria for representative design. Well, the reason is, right, we're not trying to develop skill. For transfer training of skill training, you need representative learning design. What we're doing here is focusing on action capacity. And for that, like I spoke of last year, we what we're trying to do is give you more. We're trying to increase the affordance landscape for you. So give you more potential movement solutions that you could put into the skill and make yourself more skillful, right? If I can rotate faster as a hitter, I can wait longer. That gives me more opportunities, right? I can now take an outside pitch and drive it over the wall that I might not have been able to do, right? So we're trying to push the person's action boundaries, give them more potential solutions they could use. That doesn't mean they will. So action capacity training is not necessarily going to make you more skillful, but it will if you do it in the right way. So there's different criteria. So we're not trying to so what we've been talking about in skill training, what we're trying to do is teach you how to be a movement problem solver by making sure the problems in practice meet the criteria of representative learning design. So we're giving you quality problems to make you a good problem solver. In action capacity, what we're trying to do is give you more possible solutions to solve these problems, right? We're not telling you what the solution is. We don't know. We're just giving you a wider range by increasing your ability, right? So for that, and as I said, I talked about this in detail last year. You can check out this presentation where I go to it in detail. But I just wanted to highlight some of the main points, right? When we're focusing on action capacity, right, the criteria we want to use, we want to be guided by the principles of effective force, speed, etc. generation. Not the ideal. We're not giving you the solution. We're making sure you're moving with to kind of ensure that you're doing these things, transferring force, moving quickly, right? So we say these are conditions, not positions. So the conditions for effective force speed, not the positions that might create that, having a straight elbow or this degree, right? So that's really important. Okay, so these are what we're talking about. And the conditions for effective force transfer and speed and power, right, are best represented by Franz's attractors, right? Those are the conditions that need to be met across all sports to meet these principles. We're not giving you the solution. We're making sure you have the basic conditions that will ensure that, right? And again, this is back to what we talked about before, the soft versus hard assembly. What we're trying to do is give you the ability I like to think of the difference between putting up a tent and building a skyscraper. A skyscraper is meant to last forever, right? It's a hard assembly, right? It's going to stay there. We build in a certain way, it stays there. A tent, we move around, right, to different campsites, some that have roots in different places, some that have trees closer or further from the tent, right? So we need to coordinate the tent poles and the ropes and everything in different ways each time we set it up, right? This is then a good analogy for skill, right? The constraints are constantly changing. The campsite, we need to be able to softly assemble our tent to match those constraints, right? So that's the basic idea, okay? And this is something that I get all the time, right? So I get all the time, you have to deal with players say, I don't want to do this kind of training. You made me mess up my swing, right? This kind of training you made me mess up my swing. Well, don't want to break it to you, friend, but you don't have just one swing, right? The idea that I can mess up your swing, right, implies that is the old kind of view that you have this one pre-programmed motor program, right? And this is a quote from Tristan Costas, a player for the Red Sox who had a kind of a breakout year. This is his quote: "Every swing is different, even in batting practice. Every pitch is different. Having a variety of swings to match those planes is what's great hitters great and leaves good hitters just to be average." So balls come in at different planes, different speeds, spin, right? You need different movement solutions. You need variability in your movement solution to match variability in the conditions, right? Right. So I can't mess up your swing. You don't have just one, right? So I've lost worry about that a long time ago. I used to worry about that, but I don't worry about that anymore, because making you adaptable by teaching you how to solve problems, giving you better solutions, more capacity, is going to pay off in the end. Make you adaptable to all these pitches, not just have one swing. Okay. So that's kind of one principle: conditions, not position. What we want our training is to involve variability overload, perturbations that challenge stability, right? Those are key. We want to give you a stimulus to promote change, right? When you go to a weight room, if you're going to do weight training and you do the same light weight all the time, you're not going to get stronger, right? That's not a stimulus to change. You need to push, right? Overload. You need to keep adding to the bar. That's a stimulus for your muscles to grow. Same principle here, right? So that's why we like this water bag activity. It's got load and variability. When you vary the conditions, your body needs to change in somewhere to handle all these different conditions. It's challenging your stability, right? So the water sloshing around is challenging your stability at key points in the movement. And, so we need to, that is a good stimulus for change, right? It's, and the last point here, the reason why we think this is transfer, even though it doesn't have any of the criteria of uncoupled design, is because we're not training skill here. We're training action capacity. We need that, right? So that's the point here. What we need to do when we do action capacity training, I think, is combine it with the skill training, right? So once we've given you, we've expanded your action capacity, add a constraint in practice that's going to make more likely that you use that, right? So if we're making you bigger and stronger, reduce the size of the field so you have to use that, like in soccer or a contact sport. Okay. And here's the occlusion one I like to use. If I'm using an action capacity drill that gives you faster rotational velocity, and gives you more time to swing, so I'm giving you a potential new affordance, a new solution. What I can do is an occlusion drill where you can't see the ball at the start, so you have to wait to swing. So I've added this constraint that is encouraging you to put this new action capacity into the skill. Okay. What we want to do, focus on the development of adaptability. Avoid doing kind of simple progressive increases when you're varying something this. And I've talked about this in terms of weighted ball. A lot of the weighted ball training is going from a 2 to 4 to 6 to 6. When you do a simple progression like that, you often get very maladaptive adaptations. In pitching, you get more external rotation of the shoulder. That's not what we want. That's a simple adaptation. We want to vary those things. Okay? So if we vary the weight of the ball from light to heavy, heavy to light, right, we're getting you to adapt, continuously adjust your movement control law. That's what we want, right? So the overall conclusion, the concept of representative learning design gives a principal way to evaluate where a particular practice activity is likely to transfer when we're focusing on skill, okay? Transfer to competition occurs by improving the ability to solve new movement problems, not by drilling into you a bunch of specific solutions, right? So it's a fundamental change in how we look at skill and what we're trying to do in practice. Here is something, this is in my book. If you want to go look, I've included in this last chapter in my second book. One of the ways, there's a great tool first developed by Lyndon Krause and Damien Farrow and colleagues called the Representative Practice Assessment Tool, which is a way that you can look at any drill you're doing in terms of those 4 criteria we talked about and see. I like to use it not to kind of pick on drills but where could I improve? What could I add to this to make it more representative? And there's the first paper was one of the people that helped in developing this tool. So they surveyed a bunch of skill acquisition experts. I don't know why they asked me, but they did. So they to develop this tool. So it's a really useful. Here's one in my second book. Here's one I made for baseball. So you can have a look at that. So there are tools out there to help with this. Okay, that's it for today's episode. Remember, you can contact me at robgray@asu.edu or follow me on Twitter at ShakyWeights. To find out more about the podcast, please check out perceptionaction.com. Finally, to support the podcast and receive bonus materials, including a monthly coaches meetup, please head over to patreon.com/perceptionaction. This is Rob Gray from ASU. Cheers for now, and keep 'em coupled. Gone through St. Louis.